Identify whether each of the equations below is true or false. If the equation contains variables, determine if it is true or false for all integers a and b. Circle either true or false to indicate your answer. Let's take a look at the first one. To identify if this is true or false, I'm going to evaluate the expression on the left side and evaluate the expression on the right, and then determine if my expressions are equal to each other. We need to use order of operations and simplify inside the parentheses first. The left side gives us 7 plus 5, and the right side gives us 3 plus 9, which gives us 12 plus 12 equals 12, which is true. A plus B equals B plus A. When you're given variables instead of integers, a good strategy is to choose values to substitute in for those variables to see if the statement is true. For this example, I will let A equal 5. So everywhere I see an A, I will put a 5. And I will let B equal 3. And I will see if these are equivalent to each other. 5 plus 3 on the left is 8, and 3 plus 5 on the right is 8, so this is true. 6 times 7 equals 7 times 6. That will be true because 42 equals 42. The next one has variables, so again I'm going to choose values to substitute in for each different variable. I will choose a 2 every time I see an A. I will choose a 3 every time there is a B, and I will replace every C with a 4. So again, on the right side, I'm going to put a 2 everywhere I see an A, a 3 everywhere I see a B, and a 4 everywhere I see the letter C. So you'll notice the only difference here is the placement of the parentheses. According to order of operations, we work inside the parentheses first. On the left side, I'll get 6 times 4, and on the right side, I'll get 2 times 12, and I get 24 equals 24, so that statement is true. 5 minus 8 is negative 3. 8 minus 5 is 3. Those do not equal each other, so that one is false. A minus B in parentheses and then minus C is supposed to equal A minus parentheses B minus C. So again, we're going to choose some values to substitute in for the variables. I will use 2 for an A, 3 for B, and 4 for C. So you'll notice again, the only difference here between the left side and the right side is the placement of the parentheses. I have to work inside my parentheses first. So on the left side, I will get negative 1 minus 4. On the right side, I will get 2 minus negative 1. When I evaluate the left side, I get negative 5, but on the right side, I get 3, and negative 5 is not equal to 3, so that's a false statement. 5 divided by 1 is 5. 1 divided by 5 is 1/5. Those are not equivalent, so that is false. And for the last one, again, I will choose values to substitute in for A, B, and C. I'm choosing 6 for A, 2 for B, and a 3 for C. So again, the only difference here is the placement of the parentheses. If I evaluate inside the parentheses, on the left side I get 3 divided by 3, and on the right side I get 6 divided by 2/3. On the left side, 3 divided by 3 gives me 1. Now on the right side, I still have 6 divided by 2/3. Now, we technically haven't talked about how to perform this division with the fraction, but I can tell right away that 6 divided by 2/3 is not going to equal 1, because the only way to have a quotient of 1 from a division problem is if you take a number and divide it by itself. Well, 6 divided by 2/3 is not 6 divided by itself. The only way I would get 1 is if I did 6 divided by 6. So those are not equivalent. So this will also be false. Now, really quick, let's just go back up to the top where it said determine if it's true for all integers a and b. That just means that there might be some rare cases where these statements are true for certain values of A, B, C, but they have to be true for all values in order of us to choose true as our answer. Let's take this last one for example. Say I plugged in the number 1 for A, B, and C. That would give me 1 divided by 1 in the parentheses, and then divided by 1 on the outside of the parentheses would equal 1 divided by, and then inside the parentheses, 1 divided by 1. Well, if I were to simplify this, I would work inside parentheses first, and I would get 1 divided by 1 equals 1 divided by 1. Well, that would be true because I would get 1 equals 1. But that's a rare case. That's only if I let each variable represent 1. If I let the value of each variable be 1. But that wouldn't be true for all values of the variable, as we saw over here. It was not true when I chose different values of the variable. That's why we conclude that last statement is false. Let's go back and take a look at all the true statements and identify the properties that are being illustrated. In the first one, we are illustrating the associative property of addition, which means that we can change the way numbers are grouped when we are adding them together, and we can still get the same value. So you'll notice at first we grouped the 3 plus 4, but then on the other side of the equation we grouped the 4 plus 5, but we were still able to obtain the same value. In the second expression, we are illustrating the commutative property of addition, which tells us that it doesn't matter which order we add numbers. So 5 plus 3 is the same as 3 plus 5. In the third example, we are still illustrating the commutative property, but this time it's the commutative property of multiplication, which says it doesn't matter the order in which you multiply numbers. 6 times 7 will still be the same as 7 times 6. And the last one is the associative property, but this time it's the associative property of multiplication. So it doesn't matter if I group the A and the B and find their product first, like I did here, or if I group the B and the C and find their product first. I will still obtain the same answer. Notice how at the bottom, when we tried to perform those same groupings or those same patterns with subtraction and division, they were false. So what that tells us is that the associative property and commutative property are only true for addition and multiplication. They do not hold true for subtraction and division.